Chinese EV battery manufacturer Contemporary Amperex Technology Limited, or CATL, has recently unveiled an electric car battery that has a claimed range of more than 1,000 kilometers, or about 620 miles, on a single charge. Yes, you heard it right, 620 miles, and you can expect this next-generation Qilin battery to be in production next year. The world is witnessing a massive increase in fuel prices, and people are now considering switching to electric vehicles. But not everyone is convinced to switch to an EV due to problems that revolve around EV batteries and the upfront cost of buying an electric vehicle. So why are electric vehicles so expensive? Well, the answer to that lies in the batteries that power these EVs. So stick around till the end of the video to find a lot more about the technology behind EV batteries. About 40% of the total cost of a new electric car is for the batteries, making batteries one of the most important components in any electric car. But the thing is, battery technology is not perfect, even though almost every device that we own today uses batteries to store energy. We still have not witnessed any major breakthrough when it comes to battery technology. But things have improved a lot over the last few years, and the revolutionary battery from CATL, known as the Qilin battery, with an energy density of up to 255 watt-hours per kilogram, is a perfect example for what can be done to improve the existing battery technology. This battery is here to challenge the competition because it charges faster than the existing cells while being safer and more durable. Today, Tesla enjoys a complete monopoly in the EV space because we still don't have a Tesla Challenger yet, which means electric cars can be priced keeping monopoly in mind, which leads to a higher increase in prices, and people will be forced to pay whatever Tesla demands. But the situation is changing, with more Chinese manufacturers coming up with better battery packs and offering battery swapping like in the case of NIO. The main purpose of a battery is to provide and store electricity, and companies are experimenting with different types of batteries by developing different form factors. Governments already want to reduce the level of carbon dioxide and other heat-trapping emissions, which will then act as a catalyst to drive EV adoption, especially when companies focus on manufacturing more electric vehicles. The most common kind of battery that we have in use today is a lithium-ion battery. These batteries power everything from smartphones to computers, and even your electric vehicle. Lithium-ion batteries are expected to remain the most widely used batteries for EVs, at least for the foreseeable future. The main parts of a battery are cathode and anode. Cathode acts as a battery's positive side, and anode is the negative side. A chemical solution, known as electrolyte, allows the flow of electric charge between cathode and anode. The positively charged particles of lithium, known as ions, will be moving through the electrolyte, traveling from anode to cathode. This movement creates a continuous flow of electrons to provide electricity. When a rechargeable lithium-ion battery is charged, the chemical reactions happen in the opposite way. This means that lithium ions will be traveling from cathode back to anode. It should be obvious to you now that the most important material used to produce lithium-ion batteries is lithium itself, which is a light metal substance. Other materials include metals like cobalt, manganese, and nickel, along with graphite, which is another form of carbon. A cathode in a lithium-ion battery is usually made of cobalt, manganese, and nickel, and an anode is usually made of graphite. Both anode and cathode can store lithium. The nickel contained in the cathode is responsible for high energy density. This allows EVs to travel more on a single charge. Cobalt in a lithium-ion battery ensures that it does not easily overheat or catch fire. This also helps to extend the life of electric vehicle batteries, which is why companies usually tell us that their batteries would last anywhere from 8 to 10 years. We already have companies like General Motors working on their next-generation Ultium batteries by tweaking the lithium-ion chemistry to cut costs sharply. We also have Tesla working on their 4680 battery cells, which claim to have several cost-saving aspects and other benefits because of its larger size and state-of-the-art engineering. Let's take a look at what Tesla has to offer with their 4680 battery cells. Tesla's 4680 cell is a cylindrical cell, and the name comes from its dimension of 46 millimeters width and 80 millimeters height. It is at least 5 times larger than its predecessors, and the best part about these cells is the fact that it is adopting a new tabless design, which is supposed to be a revolutionary design according to Musk. The larger cells means that there will be more space for active battery materials and less wasteful casing. The tabless design also allows the battery to maintain fast charging rates without degradation. The 4680 battery cells claimed to improve range by 54%, out of which 16% improvement comes from the cell design alone. Tesla will also be able to reduce the cost of batteries, which means in the future you could buy a Tesla as affordable as $25,000. At least that's what Elon Musk stated during the Battery Day event in 2020. Tesla is also adopting a structural battery pack, which means the 4680 battery cells will be serving as a part of the body structure linking the front and rear underbodies, and ditching the very familiar skateboard battery design that we find with most electric vehicles out there. The structural pack greatly reduces the number of parts involved, and it also simplifies the manufacturing processes to save costs. This might sound good on paper, but there are several technical issues that Tesla needs to address. For example, the larger format cells tend to overheat, which is a huge issue that the industry has always struggled with. As of now, Tesla has not been successful when it comes to producing their 4680 cells. That then limits the potential cost savings that Tesla expected, and it will also affect Tesla's ability to scale up. The increase in demand for both EVs and lithium-ion batteries resulted in higher prices and several supply chain issues for manufacturers, which is why several companies are now trying out different types of batteries for their EVs. Solid-state batteries are now being talked about as the next revolutionary technology when it comes to EV batteries. The major difference between lithium-ion and solid-state batteries would be the fact that solid-state batteries do not contain a liquid electrolyte. Instead, they have thin layers of solid electrolyte that can carry lithium ions between the cathode and anode. There's a lot of research and development that is going on to make solid-state batteries a viable choice for future EVs, but mass production of these batteries is at least 3 to 5 years away. Manufacturers who invested in solid-state batteries believe that these batteries have higher energy density. This means that batteries can be smaller and hold more power. Solid-state batteries can also charge faster and are less likely to catch fire. But solid-state batteries in their current state cost about 8 times more to produce than lithium-ion batteries. With that in mind, we already have companies like Ford, BMW, Toyota, Volkswagen, and Hyundai investing in this battery technology. But again, it's harder to draw power from solid-state batteries in the form that it's available today. So the best option that we have today would be lithium-ion batteries, and because of that, they are responsible for controlling more than 90% of the global trade market, because they store energy efficiently for a long period of time. So lithium batteries are responsible for redefining consumer and commercial transportation by reducing or completely eliminating the need for fossil fuels in internal combustion engines. The EVs of today might have the greatest tech out there, but they are still limited by the batteries that they are equipped with. Keep in mind that different electric vehicles demand different battery capacities, but most EV batteries differ in much more than just capacity. When an engineer is working on designing an EV battery system, they also consider charging speeds, degradation, cell chemistry, safety, and of course, the charge cycles. Energy and power density thresholds have also been a major factor in most electric vehicle applications. Regardless of lithium-ion battery cells or model sizes, high-voltage battery systems that power electric vehicles require a meticulously designed battery management system to make sure that maximum power and safety is delivered. A major problem with lithium is the fact that it is not the most environmentally friendly chemical element out there. In South America, huge lithium reserves are using up water by the gallon, causing devastating water-related conflicts among locals. You can't blame them, because about 2.2 million liters of water are needed to produce 1 ton of lithium. That is a lot of water. Lithium extraction can also harm the soil and cause air contamination. Yes, lithium-ion batteries can be recycled, which means that they can be used over and over again without having to mine each time. However, this is not a universally established practice yet, as not many companies are willing to take the effort to recycle batteries. The good news is that major auto manufacturers are aiming for 50% of total vehicles sold to be electric by 2030. This means that there will be a huge demand for batteries moving forward, which will force every company to work on new battery technologies. And sometime in the future, solid-state batteries might actually end up being mainstream if and only if they can fix all the issues surrounding these batteries really quickly. Ultimately, battery technology will be the next gold rush, considering our willingness to transition to sustainable energy. Companies will continue to work on improving their battery technology so that mass adoption of EVs will be possible, and we can completely eliminate our dependency on fossil fuels. But at the same time, the energy that we use to power our vehicles should also come from renewable sources of energy, and we still have a long way to go to get there.